Students, we were talking about the construction. As my phone had memory issues, the video was stopped in between, so I am again continuing the video from where I had stopped. Okay, so our aim was to increase S, that is increase the distance in the electric field, so that we can accelerate the system. Okay, so we are having electric field also, that is alternating current, alternating electric field, and we are having the magnetic field also. Magnetic field is in the outward direction. Okay, we are having hollow metallic conductor, hollow metallic conductor, hollow metallic conductor. Okay, so we had hollow metallic conductor. This is the magnetic field B, magnetic field B. Here we have the alternating charges or alternating potential. So suppose here we have negative potential and here we have positive potential. Okay, so this is the construction. Now at this point we have the source charge, which produces the charge or gives the charge. Okay, as soon as the charge is produced, suppose plus Q charge is produced, suppose plus Q charge is produced, as soon as it comes in the electric field, that is between these two. Okay, this is positively charged and this is negatively charged, so there will be electric field between them. Okay, and this charge will be attracted towards the negative part. Okay, so which means that it will accelerate and move in this direction due to the electric force or due to acceleration. Okay, so what happens as soon as it reaches this conductor? We have already studied that the electric field inside the conductor is zero. Electric field inside the conductor is zero. तो जैसे ये अंदर जाएगा, it will stop. There will be no acceleration. Okay, but जो velocity है, what happens? This magnetic field is still there. Magnetic field का ऐसा कुछ नहीं है. So what the magnetic field will do? Whenever the direction of velocity is perpendicular, okay, this is the magnetic field coming outside, and this is the direction of velocity. जब भी perpendicular होंगे, okay, you can see it this way. Suppose this is the direction of magnetic field and this is the direction of velocity. Both are mutually perpendicular. Whenever there is mutually perpendicular, what happens? It tries to convert it into a rotational motion. Okay, it will start circling itself. Okay, तो क्या होगा? यहाँ से it will start to circle itself. यहाँ पे पहुंचेगा. As soon as it reaches this point, what we need to do? We need to adjust the frequency in such a way that as soon as the charge reaches over here, the polarity should change. The polarity, that is, this will become negative and this will become positive. So क्या होगा? जैसे ये point पे आएगा, it is about to get out of the conductor. तो जैसे ही conductor के बाहर आएगा, it is entering the electric field with opposite polarity. That is, here it is negative, so the positive charge will be attracted, and so the acceleration will increase. It will increase the velocity. Okay, तो यहाँ पे पहुंचेगा. When it reaches over here, the velocity is more compared to when it was at this point. Okay, so when it reaches here, again the electric field is zero, so again magnetic field will start acting on it. So क्या होगा? फिर से circle, but this time the radius of the circle will be more. The radius of the circle will be more. Why? Because we know that R equals to mv by qb. Okay, ये हमने पढ़ा है in the last lecture only. I have told about. So when the velocity increases, the R also increases. Here you can see that velocity from here to here changes. Velocity increases. As the velocity increases, R will also increase. Velocity बढ़ेगी, R will also increase. So क्या होगा? Radius becomes big. Okay. Again, as soon as it reaches here, once again we'll change the polarity. This will become plus and this will become minus. Again it will be attracted towards this. Velocity will again increase. Again क्या होगा? It will increase the radius. Okay. And similarly the system goes on. Okay. Until it reaches the final point. Okay. I am directly taking it to the final point. Okay. Whenever it reaches a final point, it is like the diameter is almost same as the diameter of the D. At that time, what we do? We have kept here a deflector. Okay, what the deflector does? Whenever it reaches the end point, we will try to deflect it to our required position where we have a collector. Okay, यहाँ से deflect कर देंगे and it will reach the collector or wherever you want to bombard it. Okay, so यहाँ से deflect होके बाहर निकल जाएगा. Okay, I hope this much is very clear to you. So let's once again repeat very fast. What happens over here? From the source charge it gets on. Okay, source charge से the positive charge comes out. Due to electric field it is attracted over here. Okay, with acceleration the velocity increases from here to here. यहाँ पे आगे क्या हो जाएगा? Electric field becomes zero. so it will start rotating because of the magnetic field. Okay, rotation start होगा, यहाँ पे पहुंचेगा, क्या होगा, once again it will be about to enter the electric field. At that time we change the polarity due to the frequency. Okay, तो उसकी वजह से frequency change करेंगे तो क्या होगा, it attracts, the positive charge is attracted on this side, so it will try to accelerate, and due to electrostatic force it will accelerate, and same way it keeps on rotating. Here what happens, as it is moving from here to here, the velocity changes. As the velocity increases, the radius also increases. From here, r is equals to mv by qb. If v increases, radius also increases, so the radius this time is bigger than this one, and each and every time the radius keeps on increasing. Okay, I hope this much portion is very clear to you. Then we'll move towards the last part. Okay, one thing, we need to set the frequency of it, frequency of changing the polarity. Okay, here we have studied that time required for one rotation, time required for one complete rotation is 2 pi m by qb. This we have studied in the previous lecture only, when we are discussing the case of perpendicular b and v. When v and b are perpendicular, then it moves in circular motion. At that time the time is this. Okay, and if this is the time, what is the frequency? Frequency is 1 upon t, that is qb upon 2 pi m. Here can you see one thing, that it does not depend on v. Okay, it does not depend on v. So if it is not depending on v, then the time period to complete this rotations for all the rotation will be equal. इतना rotation complete करने में भी उतना ही time जाएगा जितना ये बड़ा वाला rotation में. Okay, because as the velocity is also increasing and the diameter is also increasing, so the time period for this is same. So you need to set the frequency to this. Okay, ये frequency ऐसे set करनी पड़ेगी कि whenever the electron or the charge is about to exit the conductor, the polarity should change. As and when the charge is about to exit one of the conductor, the polarity should change. Okay, so this frequency we can set according to it. Okay, now if we talk about the energy, what will be the final energy? Okay, energy will be in the form of kinetic energy, and we know what is the formula for kinetic energy, half mv square, half mv square. Okay, what is the value of v? Here m is constant, only v is changing. What is the value of v? We can take it from over here. Value of v will be, I'll write over here, v equals to r qb upon m. Okay, so I can write according to this, half m, what is v square, that will be r square q square b square upon m square. Okay, this m square can be cancelled out, so your final formula will be r square q square b square upon twice m. Okay, this will be your final formula or the final kinetic energy that the charge will have. Okay, this will be the final energy that the charge will have. Okay, I hope you have understood what is exactly the cyclotron. It keeps on moving the charges, which ultimately increases the distance. What we are aiming, we were aiming to increase the distance in the electric field. Okay, एक ही फील्ड में क्या होगा, बार बार वो रोटेट करेगा. If it is rotating more times, क्या होगा, every time it is accelerated. Every time it is accelerated, the velocity increases. So ultimate velocity, we get a very high velocity. Okay students, I hope you understood it. Keep studying. All the best. Have a nice day. Thank you.